Hello, welcome back here. In last lecture, I was explaining how the values of the mapping are stored in the storage and how we can retrieve them. In this lecture, I would like to talk just very quickly about the size of the mapping and the size of the storage, why the size is 2 to the power of 256 minus 1. Okay, this lecture will be a lecture, so additional information lecture, and you can skip it. Okay, so now without any further waiting, let's take a look at this size, why the size of the storage is especially this number. All of this is related to function Keccak256. As you can see here from the name, you can deduct that this will return you the string, the value of the 256 bits. Okay, so this number you are getting in a hexadecimal format. You can copy it, you can go back to your conjugator, you can basically encode here anything, right? We need to change it for a text. Anything, and this will get you this value. And this value is in a hexadecimal format, and it should have 64 characters. This means 32 bytes, which means 256 bits, which means in a decimal this is some specific number. This is in a decimal some specific number. In the binary, it's a specific sequence of zeros, and ones. Okay, so all of this is related to Keccak256. Everything is related to this number, 2 on the power of 256 minus 1, because the resulting value is the size of 256, and this number can be in the decimal only, I will mark it here, 2 on the power of 256 minus 1. And why is that? Okay, first, let's see binary representation of this number. Okay, so I'll copy it. I will go back to browser. Let's go to hex to binary. All right. Let's get it here. Convert, and you will see you are getting this specific number as a sequence of 256 bits. All right. I'll copy this. I'll just to you believe me. Paste it here. Let's select all the lines. Select all the characters, and we'll see. In total, we have here, actually, just 254 in this case, because probably we skipped the first, we skipped some zeros in the front here because they were redundant. Okay, so that wasn't the the best example I showed you. Let's try this previous characters we had here. Maybe this will be bigger numbers. So let's try this one. Okay, all right, not the best example, but let's copy this one, convert, copy the number of characters here. Okay, here, actually here, we reached the maximum, 256 selected. Okay, that's a sequence of ones and zeros. So in the total, the biggest number I can keep here will be the sequence of 256 ones. That's the biggest number I can keep, 256 ones. And this number is this, 2 to the power 256 minus 1 in the decimal. Okay? That will be maximum number. Let's explain it on the smaller number, okay? So we will get a picture. Okay, I can actually, I have here some space, right? So perfect. Okay. So let's imagine we have a 1 byte number. Okay, so we have a uint of 8. Uint of 8. So 8-bit number. This means the maximum value we can keep here will be 8 1s to zeros. Maximum value will be 8 ones actually. So 1, 1. I'll make it very more space. So 1, 1. 1, 1, 1, 1, 1. So 4, 8 ones here. That's the maximum number we can keep in a uint 8. And this value, I can tell you, will be the 2 on the power of 8 minus 1. This would be as with the uint 256. So 256 bits would be 2 on the power of 256 minus 1, right? So let's get actually count this number. What will be value? First in a calculator. Okay, so 2 to the power of 8 minus 1. Yeah, 255. Yeah, that should be it. Just one more time. Just misclicked something. 206. Yeah, minus 1. Okay, perfect. Okay, so that's the biggest value, right? So we can keep here will be 255, which we can keep on the 8 bits. Okay, we can verify it also. Okay, so we can see here when I will get here that's a 2 on the power of 0, 2 on the power of 1, 2 on the power of 2. So this value can keep 1, this 2, this 4, this 8, this 16, this 32, this 64, this 128. Now we need to get it all together. Okay, so we can count together. All right, just want to make a mistake. I will put it in fast to calculator so we're not spending here time. So we have 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, 255. Okay, so this value, counted also on paper, is 255, and you can resolve it with this formula here, number of bits, 2 to the power of number of bits minus 1. And the same apply for a Keccak 256. Since it can return maximum 256 once, the maximum value will be the 2 at the power of 256 minus 1, which is super large number, I can tell you, and that should be enough than for your storage of items. I was reading that's the entire number of the atoms in the universe. That's how big is this number when you will count it. Okay, so you can also put it here into this converter. You can place here 256 ones, and you will get even this value. What we got here is big enough. We'll see how big is this number. This number has a 77 decimals. So that's how many. If you will store so many items in your storage, yeah, that would be really amazing. I cannot imagine that. Oh yeah, so that's just for this AI lecture. So now I hope you have a better understanding of what the values we are getting. Again, everything on a binary on the base level is a binary sequence of zeros and the ones. Here you are getting in a Keccak hexadecimals, but in the end, that's just some specific binary sequence you can also get as a decimal number. Okay, this is just this conversion we are using. Okay, that should be it. Let's talk in the next lecture again about the storage. I will show you how the arrays are stored in the storage, and then we'll continue with our contract again. Okay, guys, so hope to see you in the next one. Cheers.